Okay, so looking at this is, you've got the A, the things that's going to give you the transformations. You've got the A, the B, the C, and the D. Okay, so first, we're going to talk about the A and the D first. So the A, it is going to be a vertical stretch if A is greater than 1. It is going to be a vertical compress if A is between 0 and 1. And then the last thing that A value can do, and it's not up there, so just write it underneath. If you have a negative A value, it is going to reflect across the x-axis. The D value at the very end, this one's easy to identify because it's the number. If it's there, it's at the very end of the equation, all by itself. It's not in a set of parentheses. And it is going to be a vertical shift. But if it is plus D, it is going to move up. If it is minus D, it is going to move down. So, I talked about the A and the D together for a reason, because they are both vertical transformations. If it is a vertical transformation, is that going to affect the x values or the y values of a graph? The y values. So everything that you're going to see outside the set of parentheses, okay, you look at some of these examples down here, the 4, the 1/5, the -3, the 1, the negative. All of those are outside the parentheses. Those are all going to affect the y values of a function. Everything inside is going to affect the x values. So, for the b value, it is going to be a vertical stretch if the b value is between 0 and 1. It is going to be a compress if the b value is greater than 1. Now, whenever you're doing that, and you can kind of write this up here, or wherever you got space, whenever you're actually applying that number to the graph, you're going to use the values reciprocal. Somebody tell me what a reciprocal is. Meredith? It's where you got a fraction and you just flip it. Okay, so the reciprocal of 1/5 is 5 over 1. Okay, the reciprocal of 3 is 1/3. So you would do this. Okay, b is greater than 1, so it's a vertical compression. But then you would multiply all the b values by 1/3 to horizontally compress it. Okay? And then, just like the a value, it's got that negative rule. But for the b, it's going to reflect across the y-axis. Yes?
So, if it's greater than 1 and it has to compress horizontally, would you just number 5? Would you say?
Now the c value. So the d value moves it up and down. The c value is going to move it left and right. So common sense that plus C would tell you that it's going to move which direction? Common sense would tell you that it's going to move to the right, but it is going to be left and right opposite the sign. So against common sense. Plus C is going to move to the left. Minus C is going to move to the right. So whenever you're looking at these equations, know what it's going to affect, the X or the Y, kind of based on where it's at. If it's inside the parentheses, so looking down here, this minus 2, this 3, this negative, this 1/4, all of that is going to affect the X values. And you got to be careful with that because it's all kind of opposite of what you would think. With the B value, you got to take the reciprocal. With the C value, it's opposite the sign. The vertical stuff is easy because the number that's in the equation, you're going to use that exact number. That whenever it's a horizontal, it's different. One thing that kind of clicks with some people, and it's kind of a weird little analogy, but raise your hand if you watch the show Stranger Things. Does anybody watch that? Okay, so a good enough number of people in here. So, if you remember, especially in season 1, you know, everything was fine, and then whenever they went into whatever, the little portals, they were now into the upside down, and everything was kind of backwards, right? It was kind of weird. So inside the parentheses, that is the upside down. Everything's off a little bit. Or at least in the show, it's really off. It's really weird. All right? Everything outside the parentheses, everything is as it appears. It's the real world out there. Okay? Whether it's the A in front or the B outside. So whenever you're dealing with the transformation that's inside the parentheses, you've got to be careful with it, with how you apply it to the graph. Okay, so that's, if you watch Stranger Things, you know that might make sense to you. And if not, then I don't know what you're doing with your life. You need to go watch Stranger Things. So. So let's go back to page 7. So now we're going to kind of go through, again, I'm going to go through a couple examples. I'm going to get you started on it. Okay, so again, we're going to use this as the parent function, so we need to find the basic information about this. Looking at this graph, whenever x is -3, what is the y value? 0. Whenever x is -1, what's the y value? -3. Just kind of going to the different points that are on the graph here, guys. Whenever x is 0, what's y?
1.
Whenever x is 1? Whenever x is 2? Whenever x is 3? Okay. It's not written, there's not a spot for it on here, but we need to write the domain and the range for this. Because every problem you're going to have from here on, you're going to write the domain and range. What is the domain for this graph? -3 to 3. What is the range? -3 to 1. So go into this first one. We'll do an easy one here. Then I'll do a few that are a little more difficult and let you finish the rest. So that +2, is that the C or the D value? D value. How do I know that it's a D value? It's outside the parentheses. Okay. So if it is +2, which direction is this going to go? Not if it's the D. D value is up and down. It's going to go up 2. Is it a vertical transformation? So is it going to affect the x or the y values? So I need to take each y value and do what to it? I'm going to add 2. Make sure on each problem you write what you're doing to either the y or the x values right there, so that whenever you refer back to the notes, you know where we got all these new y values. So what is 0 plus 2? 2. And if you want to write it out every time, that's fine. I'm just going to do it on the first couple here. And I'm just going to go through and I'm just going to add 2. To each y value. Now whenever you come over here and graph it, you can do each individual point, -3, 2, and count and go there. But if this parent function's already on there, I can just go to each point, go up 2, put a dot, go up 2, put a dot, up 2, because I'm taking each individual point and I'm just moving them up 2. So if it's a vertical transformation, is that going to affect my domain at all? No, it didn't move left or right. So my domain's the same. Gavin, what would my new range be? What's the lowest y value? -1 to what? -1 to 3. Okay. Now that you have that, I want you to go to problem number. Let's go to 5 real quick. So I have a negative at the very beginning of the equation. What is that transformation? It's going to reflect across the x-axis. Does anybody have an idea which, if it reflects across the x-axis, that's a vertical transformation, so it's going to affect the y's. Does somebody have an idea as to what I need to do to all the y values? Change their sign. Okay. Now, mathematically, how you would get that is you're going to do -1 times y. And that's just going to change the sign. Now, if you've got 0, it's going to stay 0. But then I've got -3, that turns into +3. I've got 1, that's now -1. 0, -1, and 0. And now I can go through and I can graph those points. So I've got -3, 0. But then I've got -1, 3. 0, -1. 1, 0. 2, -1. And 3, 0. Because it's a vertical transformation, that is not going to affect my domain. And then my range, I would just need to look at the graph. Bottom's at -1, the top is at 3. Okay. Questions on that? All right. Next, I'm going to do one of the harder ones with you, which is a B value. I'm not going to do either one of the A values. I want to see if you can figure out what to do with these and doing the b value will probably help you out a little bit. But with the whole reciprocal thing, this makes this a little tricky. So I've got a b value of 1/2. 1/2 is between 0 and 1. Hopefully we all agree with that. If it is a b value between 0 and 1, what is that transformation?
Stretch.
Okay. Horizontal or vertical?
Horizontal.
Okay. So I'm going to say that it is a horizontal stretch by what? By 2. Because I need to take 1/2's reciprocal. Okay. It's horizontal, so it's going to affect the x values. So if it's a stretch or compress, what do I need to do with the x values and the number 2? Multiply them. So kind of remember that whenever you do the vertical stretch, vertical compress here in a minute. So I'm going to go through, I'm just going to multiply all of those by by 2. So 2 times -3, 2 times -1, 2 times 0, 2 times 1, 4, 6. So whenever I graph this, I've got -6, 0. I've got -2, -3, 0, 1, 2, 0, 4, 1, 6, 0. If it is a horizontal shift, what is not, a horizontal transformation, what is not affected, the domain or the range? The range. It's still -3 to 1. What is my new domain? -6 to 6.